All right, let's get going. Thank you all so much for being here. It's a pretty packed talk slot with lots of other great talks, so I'm very honoured that you've chosen to come and listen to me talk for an hour. My name is Eli, and I'm here to talk to you about how we talk to each other. This talk is about communication and how we can communicate better as people, as software developers, and the ways that learning about this can make our lives a little bit easier. So, this talk came about as any of you who came to my talk this morning about the history of data storage, there was a pretty big omission in that talk, which is about, we store data by getting ideas out of our head and putting them into objects. But that process is really actually very complicated. And once you have an idea in your head, how do you get it into a state where you can write it down or even communicate it to another person? This problem shows up all the time in our daily lives. It shows up when you are in our work, for example. It shows up. Has anyone ever had the situation where you're like 2 weeks into doing some work and you realize that actually you've been working on the wrong thing? You've disagreed with a stakeholder about what the meaning of some words were, and now you've actually been doing the wrong work. It shows up obviously in our daily lives all the time, with just in terms of interpersonal communication. And so that's what this talk is about how do we get ideas from our heads into other people's heads? How does that process work? And to do this, I'll be taking you through a journey through the history of linguistics and some theories of communication that we can look at to help us inform how we think about this problem. So here's what I think is going on when we talk to each other. There are two people. Without loss of generality, here's me on the left and here's you on the right. And I have an idea in my head. And in order to try and get this idea into your head, I say something or do something. I maybe say some words. I maybe write something on a keyboard, write something on a computer, for example, write something down. And this causes you to perceive something, whether that's hearing the words I say, reading the words I write, seeing me make some kind of visual gesture. And then that causes you to have an idea in your head. And this is the general model that I'm going to be using. I'm sorry about the contrast of some of this. This is the general model I'm going to be using as we go through this talk today. And with the talk that I gave this morning about storing data, the bit that I was really going into was this sort of extra step in the middle here, where what I say and what you perceive might go through an intermediate step where we turn it into a physical object, like writing things on paper or storing or sending it as JSON across the web or whatever. But for the purposes of this talk this afternoon, we're not going to care about that in particular. We're going to focus on this sort of stripped back model of I have an idea in my head, I say something, you hear something, you think something. And one of the biggest problems that we have when we try and communicate is the fact that these translation layers, they are actually translation layers. They are actually transformations. What you think and what you say as a result, those aren't necessarily equivalent. There might be multiple ways to say the same thing, or multiple things you might mean when you say a given phrase. So, for example, the word run in English has like a zillion different meanings. It's like something like 640 different meanings. And on the flip side, having multiple ways to explain the same concept is something that I learned firsthand when I did some maths tutoring during my degree. I was struggling to explain how logarithms worked to a particular student, and the way that I wanted to express this understanding did not cause that understanding in her head. I had to think of a different way to express the same idea in order to get her to have that light bulb moment. So this layer here, between what I say, what I think, and what I say, is genuinely a transformation layer. It can be many to many. And the same is true for when you hear something and the ideas that you might have in your head as a result. So this model makes very clear that things are different. The ideas that we have and the things that we do in order to communicate those ideas are not the same thing. But obviously, they have a relationship to each other. That's how we're able to communicate. And in order to think about what this relationship is, how we can think about this relationship, I'm going to introduce to you our first philosopher of the day. This is Ferdinand de Saussure. And he lived in the second half of the 19th century, pretty much. And one of the things that he did that we particularly care about, he was a founder of linguistics, essentially, as a field, as we know it. And the thing that he did, and the ideas that he introduced that we care about, is a field called semiotics, which is essentially the study of meaning and the study of signs. And what he did, the idea that he introduced, was the concept that these two things together are a sign, and a sign conveys meaning. And so what we have is the thing being signified by a sign, the idea in your head. And then you also have something called the signifier, what you do in order to signify this meaning. And this is a bit wordy, and I am going to stumble over these words. So instead of saying signified, I'm going to say concept. And what Saussure said was he basically introduced this idea that these two things are separate and related, but the idea that they don't actually necessarily intrinsically have anything to do with each other. Prior to Saussure sort of proposing this theory, people had the idea that the words we use to describe concepts had some kind of intrinsic metaphysical relationship to the concepts in question. But we could know this isn't true. So for example, here's an animal. And in ancient Egyptian, this animal is called a mao. And it's pretty obvious if you've ever interacted with one of these animals to know where that name came from, right? But in English, it's a cat. And why that has no obvious connection to the idea of this creature. Why those sounds, right? But we can still use those sounds to denote this creature because we all have a shared understanding of the relationship between the concept and the signifier, these sounds, cat, that we're using to talk about it. And this is something we actually, it sounds very abstract, but it's something we're quite familiar with, the idea that the ways we use to communicate certain ideas don't necessarily intrinsically have anything to do with the ideas we're communicating. So for example, memes, right? You know, all of these images, does anyone here not recognize any of these? Okay, cool, I've judged it fairly well. So, you know, these all have specific meanings, but why does this picture mean, I don't want to be involved in the situation that's going on here? Why does this picture of Kermit, why is this picture of a green frog puppet drinking tea? Why should that mean someone I don't like is having a bad time because of it's their own fault? And I'm trying not to be petty about it, but I'm really being quite petty about it. Like, that intrinsically, a very complex concept. And this image doesn't have anything to do with it, like, intrinsically, right? But because we have communally agreed that this signifier, this image, has a relationship to that concept that we're signifying with it, we're able to use it to communicate. So, coming back to this idea, right, in this framework, and if we take another look at these sort of translation layers, so we've understood that we are able to have these kinds of translation layers because of these relationships between the things we try to signify and the ways we try to signify them. Another thing that I really like about this model is that it makes clear that the idea in my head, in your head, and the idea in your head, they're not the same. And actually, I would argue that intrinsically, we can never actually compare these two things directly. You can never actually extract an idea out of someone's head without going through that translation process of translating the concepts into signifiers. So these two things, it's not even apples and oranges. You can never actually compare these two things. The only proof we have that we're able to communicate effectively is in the ways that we externalize the ideas in our heads. And when I first, Mike's cutting in and out, hello. When I first gave this talk, it was in Porto. And in Portuguese, there is a word called, saudade. Does anyone know what this word means? Are you Portuguese? Okay, would you like to translate it for me? Exactly, there is no English translation. And I'm so glad you're here for this. Right? There is no English translation of this. And there are ways to describe the concept that is signified by this word. But it's the point I'm trying to make here is that there is an idea that you have in your head as somebody who can understand this word that I don't have in my head. There's no concept for it to map onto necessarily. And I will come back to this word as well once we have looked at some other frameworks for thinking about communication. So one of the things we have when we have this concept and signifier relationship, right? We understand that this relationship exists. It must do because we're able to communicate. But how can we actually know, how can we investigate this relationship? Do we just take it for granted that these relationships emerge? How is it created? How is it shared? So Saussure had another idea that's relevant here, and it's called the speech circuit. And the way that it works is, here's a person and they have an idea. And to express this idea, they do something or say something. They externalize some kind of signifier, right? And that is called the parole. Every time somebody does that, a parole is like a speech act. It's an instance of speech. But there is also the long, which is this abstract idea of the collection of relationships between signified things, concepts, and signifiers. And understanding this long is what enables us to make acts of speech. We use this sort of translation engine in order to turn ideas into acts of speech so that they can be understood. But one of the things that Saussure said that was also at the time quite revolutionary is that your acts of speech inform the long, this shared understanding we have of how to turn ideas into communicable actions. And one of the ways we see this is in slang, right? So, for example, we're here in Sydney, we're here in Australia, and the same words can have quite different meanings from the way that they do where I'm from in the UK. For example, one four-letter word that has this quality is mate. There are others, and the way that they are used in language, in communication, informs how we use those words. It all cycles back around, right? And this is what's called Saussure's speech circuit. And this is what enables us to share and continuously contribute to the mechanisms of communication that we have. This is why this picture of Kermit drinking tea means somebody I don't like has brought a bad situation upon themselves, and I'm not going to be petty about it, but I'm kind of being petty about it. Because we have created this meaning through the actions of engaging in that speech circuit, Saussure's speech circuit. But this speech circuit depends on this concept of the long, right? And so how can we understand this kind of translation engine, something which doesn't exist without people? It's entirely constructed, it's entirely a social construct, but it exists outside of any one person's head. When linguists engage in their field of study, this is a thing that they're really interested in. What is this shared understanding of communication that we have? How can we investigate this? How can we describe it? What rules does it operate under? How does it behave? How does it change over time? And in order to look a little more closely at this concept, we are going to meet our second philosopher of the day. This is Ludwig Wittgenstein, and to some people, myself included, he is like the philosopher of all time. He was active in the first half of the last century, and just one of the most sort of influential thinkers, honestly, of all time. There was not really any field that he didn't touch on. So logic, mathematics, language, a lot of the things that informed the talk that I'm giving today. So I had a great time reading through some of his writing in preparation for this talk. And the thing that he wrote about that we're particularly interested in today is the concept of a language game from which this talk gets its name. He said that like games of chance or skill or athletics, the way that we communicate has rules that we must obey in order to be understood. And that like games of skill or chance or athletics, these rules can differ in different circumstances. So when we think about the relationship between the concepts in our head and the things we do to signify them, the rules of a language game is what gives us the means to do this translation from our ideas in our head into spoken language. And they provide a bridge between concepts and signifiers. And these rules are shared and understood by all players of the game. It's a pretty abstract concept, and he mostly described it through the use of analogy and example. So I'll do the same. Let's say we have a couple of software engineers and they are building some Lego together, because software engineers all love Lego. And they are building, they're building something, and the thing that they're building uses these three pieces of Lego. And these three pieces of Lego are called a jumper, a brick, and a plate. Let's call our software engineers Dylan and Hannes, for example. And they're building things together. And Dylan says to Hannes, brick. And Hannes passes him one brick. And then Dylan says to Hannes, plate. And Hannes passes him one of these, the things that look like this. And then Dylan says to Hannes, jumper. And Hannes passes him one that looks like this. They're playing a language game together, a language game with a very limited set of rules, where each of those words, like brick, jumper, plate, have the specific meanings of pass me one and precisely one of the objects that look like that, right? But the thing about this language game is that the rules are sort of arbitrary. If they had chosen the colours of these Lego elements instead of the names, pink, white, and blue, there would be one fewer syllable, right? Pink has one fewer syllable than jumper. That would actually have been more efficient. But they chose the rules of that language game. They chose to use the specific official Lego terminology for each of these elements because they're nerds and it makes them happy to use the official terminology. So the rules of the language games that we use aren't necessarily chosen for efficiency. There are always human elements to these aren't logical, but they are still rules nevertheless. So if language is a game and there are rules that we have to abide by in order to be understood, in order to communicate efficiently, what does it look like when we break those rules? Well, here's an example. I'll give you a moment to read through this. This doesn't make sense, right? This sentence doesn't mean anything. It looks completely grammatically sound, but there's no way to interpret this sentence that actually makes sense. This type of sentence is called a comparative illusion. So if you want to go and look up more examples, this is a fairly well-known one. And each element, it sounds perfectly sensible, scans very well, but it doesn't mean anything. It breaks the rules of language. And there's a very specific grammatical way, a very subtle grammar error in here that you can go and look up the specifics of. But the thing is that even to a native English speaker, I look at that and I go, that scans perfectly reasonably, right? So that breaks the rules of language. It doesn't mean anything. Here is another sentence. Right, we can all agree this is nonsense, right? Does anyone want to guess what this means? I say this in my household frequently, if that helps. This means we need to trim the nails of my cat, precisely. The cat is the baby. Sometimes she gets too sharp, her claws get too long and she's scratching at things. The baby is too sharp, we need to unsharpen her. We need to unsharpen the baby. And we say this in my household. And the reason that this makes sense in the context of my household is that, like with a board game, the language game we play in my household, we have house rules. Does anybody here play as a Monopoly, for example? There's lots of rules that people play with in Monopoly that are not in the official rule book, but you play with them anyway because they make the game more interesting, they make the game better experience for you and the people that you play with. And as long as you agree together on what those rules are, you can use them. So that's what we're doing in my household. The baby means the cat. And outside of my household, that rule doesn't apply. And so I'm not able to be understood when I say things like this. The big thing that Wittgenstein said here is that context is the thing that sets the rules for a language game. This was groundbreaking for his time. Just like when Saussure said that the things we use to signify concepts don't intrinsically have a relationship to the concepts they signify, the idea that context is actually not just useful, but fundamental to the way that we communicate, this was groundbreaking. To me, they are kind of saying the same thing, that, words, sounds, language, gestures, when we talk about sort of visual language and sign language, without a given context, they do not have meaning. And with only partial context, we lose nuance. So coming back to the word saudade, we can understand a bit more about why it's untranslatable. It's dependent on a very specific cultural context. So please correct me if I get any of this wrong. My understanding is that this word describes a very specific feeling of people from Portugal when they came over to Brazil for the first time. And they were looking back and in the moment where you're looking forward to a new and uncertain future that's full of potential and promise, but at the same time looking behind you to what you've left behind. And it's this very specific bittersweetness and sort of longing, wistfulness. And perhaps I can never understand that word properly because I wasn't one of those people. And I don't have that shared cultural context and that shared knowledge and that shared history. I don't have the context to understand this word properly. I'm not part of that language game. So maybe I can never actually fully understand this word and I can only ever observe it from the outside. So context sets the rules for a language game. And if you do not have the context, you cannot play the game. This raises an interesting question because by and large, in this room, right, we all speak English to a certain degree, English that you are, certainly well enough that you are confident to come to a software conference that is conducted in English and get meaning out of it. I only speak English pretty much. So if you speak more than one language, you are doing, I respect that immensely. But But it's not always the case that we will share even that much context with somebody else. What if we didn't share context with a person that we're trying to communicate with at all? This is actually a real problem that we have, or that we will have, and we need to prepare for. Does anybody recognize these words? Has anyone seen this before? These are, this is a long-term nuclear waste warning message. So there is an institute, I forget the exact name, and they have a mandate it's the Institute for Long-Term Nuclear Waste Storage or something. And they have a mandate to try and make sure that the nuclear waste that we generate today as part of our energy production is stored safely and does not cause harm to people in the future. And we're talking about things that have nuclear waste that has half-lives into the tens of thousands of years. We have no idea what the cultures, the languages, the context of people in that time frame is going to look like. 10,000 years is longer than the span of any one human civilization. It's longer than the lifespan of any one language, pretty much. How can we possibly communicate these very specific contexts of here's some really dangerous stuff that we've buried, do not dig it up. And this message, This is Not a Place of Honor, is part of a series of short messages that this institute has come up with. And the goal of these short series of messages is to determine, in as sort of broad a sense as possible, what we want to convey to people who come across nuclear waste disposal sites. And the messages start out broad. This is not a place of honor. No great deed is commemorated here. And then they start getting more specific, like the danger is to the body, the danger is present in your time as it was in ours. And as you go through the messages, you get these more and more specific things that will require more and more shared context to reliably communicate. And it's a really interesting problem because we have no idea how the people that we're trying to communicate with in the far future are going to be able to interpret our messages. And to illustrate this, I'd like to take you through one of the graphics that they have designed in order to try and address this problem. This is ISO 21482 2007. This is a standard image. And you can see here, this is the idea here is that you would put this image up on a build, on some physical piece of hardware that's not going to degrade too fast. And people will be able to look at this and have some understanding of the concepts of this is not a place of honor, do not dig here, you should probably stay away. And the way that this message is constructed is really interesting to sort of break apart in terms of what we know about people in 10,000 years' time. We can assume that they will probably have skulls and bones that look quite like ours. And we can assume that, much like us, you don't generally see those unless something's gone very wrong. We bury our dead, by and large. We have done for tens of thousands of years. We don't see, in real life, skull and crossbones, right? Except in the situation where somebody has died badly. And we can assume that this will probably be true in 10,000 years. This is probably a pretty good guess at a symbol that is going to be meaningful as bad, no bueno to people in 10,000 years' time, right? We can also assume that people in 10,000 years will have roughly the same body shape. No, that's not long. Oh, Mike, that's not long enough for people to develop an extra set of limbs, for example. This image will probably be recognizable as a person to people in 10,000 years. The arrow, well, we can hope that people will understand that this is a person running in a certain direction. But this is a pretty good guess that this will be interpretable to people 10,000 years in the future as leave, like move. Now, the last bit is the one that's really difficult to convey because nuclear radiation is a very specific and abstract concept. This is, we hope that this symbol for, nuclear, that's meaning sort of nuclear things might persist and that might still be understood in the future. We've got these sort of rays that are emanating out with, again, the arrow. But this is really a kind of a stab in the dark because if we don't know about anything about what these people's context is, we have no idea that they'll interpret this in the right way. But it's about as abstract and simple as we can boil it down to. But if you look at this again, this is our best attempt, and it's pretty good. You can understand why each element is the way it is. But as my friend Dylan pointed out to me, another interpretation of this image is if snakes come out of the propeller, run away from the pirates. Like, this is an extreme example, right? But I love it because this is what we're doing every time we try and communicate at all. And it's one of the things that's really scary about giving this talk, because I have no idea that what I am trying to say to you, the ideas that I have in my head, are making it through unscathed. And what does unscathed even mean? You know, the pink light bulb and the blue light bulb, they are different. This is all we're doing anytime we try and communicate. And this is what I mean when I say in the abstract that, like, imperfect communication is not a failure. It's the best we can hope for. And we've been getting by as a species. Good enough has been good enough. But there's another angle to this particular example too, which is one of the other reasons that I bring it up, which is how to make sure that information sticks around. And it's something I spoke about this morning when I was talking about data durability. How do we make sure that if we have information, that information persists over time? Things like signs, physical signs, will degrade, especially if it's near somewhere where there's lots of radiation, right? Verbal messages get warped and changed over time with repeated transmission. One person came up with an idea when it comes to long-term nuclear waste storage that I think is really hilarious, but it's also really interesting and potentially workable. So we come back to this creature, and this is a creature with which humans have had partnership for a long time. Not as long as dogs, but if you try and sort of do a silhouette of a dog, right, a dog is less recognizable because we've bred them so selectively that a Chihuahua and a Great Dane are the same. They're not the same thing, but, you know, whereas cats or mouse have stayed pretty much fairly recognizable over the tens of thousands of years that we have been in partnership with them, or sort of symbiosis, mutual relationship with these animals. And it's reasonable to think that this will continue into the future. People like cats. People will probably continue to live with cats. There will probably continue to be feral cat populations wherever there are people. One of the things that we can do these days, because science is awesome, is we can genetically modify cats that will glow in the dark in the presence of radioactive emissions, right? This is a thing we can do today. And one person who is, I don't know if he was associated with this institution, had the idea that we should do this. We should breed these cats that will glow when there is in the presence of radioactive emissions. And we should sort of just release them and have them be part of the random bred cat population from which we take the animals that we have as pets and the animals that we have that live with us on farms, for example. And the purpose of this would be to try and instill into a human population the idea that if your cat changes colour, that's bad. You should leave the area, right? If your cat starts glowing, you need to move. And in order to try, because that's a much more simple concept than snakes coming out of the propeller, right? And so in order to try and perpetuate this idea, this person also, and I've completely forgotten his name, I'm going to have to Google it afterwards, but he came up with the idea of how do we preserve knowledge for a long time through perhaps an oral tradition in people. And one of the ways that we do this is with music. Songs with lyrics, particularly simple lyrics, are able to convey specific messages over time quite well. So he came up with a song. He wrote a song called Don't Change Colour Kitty. And if you want to know more about this person, that's the phrase to Google. And the idea is that we will sing this song to people and that knowledge will be preserved so that if people go, oh my God, my cat's glowing, wait, don't change colour kitty, I need to leave. Maybe that'll save a life, I don't know. But I really love this idea because it's drawing on things that we know to be fairly consistent about humans over time. Not something so culturally and context specific as all the words I'm saying to you today, but ideally that this message could persist into the future, aided by a little bit of genetic magic. And it's true, we do know about as a people, we do know about the power of music to carry a very specific cultural context, right? Music can convey meaning. Right, I promise that's the last meme for this talk. So we come back to this model, right, of communication. And this is, we've talked about a couple of philosophers and their ideas about communication. We've understood a bit more about how we talk to each other as people. And this is useful for us in our work, simply about being in meetings and making sure that when we use the same word, we've got something of a similar light bulbs in our head when we say the word run, or we say the word cloud, or asynchronous, for example. But this is also a tech talk, and I want to talk about what some of these ideas mean for us as people who talk not only to other people, but to computers. Because when we do software engineering, we do a little bit of this, but we also do this, right? We're trying to talk to computers. You've got an idea in your head, you've got something that you want done, and you're trying to communicate to the computer what that thing is so that the computer can do it for you. But how can we talk to computers? They have no internal concept of any of the things we've been talking about. They have no signified things going on in their heads. Well, we start with machine code and we build up layers and layers of abstraction, add rules into our language game, syntactic sugar, until we get something that we can reasonably call a programming language. And so programming languages are just sets of rules for language games. When we've defined a language that we can play with in common with the computers that we use to do our work for us, we teach computers what signifiers mean, things like if and when, and what open curly braces mean in the context of the language we're writing in. So one of the things that is interesting to me about this is that this bit pretty much is a solved problem, right? Like this is what programming languages do. Is you take words like, I'm a Python person, and you can write something that scans like fairly readable English almost, and get a computer to reliably do a certain thing. You can get a reliable output from a computer by putting in these particular words. And so as software developers, software engineers, a lot of what our job is getting better at this bit, getting better at taking ideas from my head and turning them into code. And this is something that, a lot of us, particularly the kind of people who come to software conferences, we get really geeky about this. We're going, okay, well, like, what's the most efficient way? And we're talking about domain-driven design and stuff, which I will come back to. And like, what's the best way to get ideas from my head into code that a machine can operate on? And this is getting close towards a solved problem too. Like, just get good at code, right? Like that's the idea of so that's where the difficulty is in this model, honestly. And one of the interesting things about recent technological developments is that with the introduction of large language models and prompt engineering, we've reintroduced uncertainty and inscrutability back into this half of the diagram. If I've prompted an AI to do something, I can no longer sort of go and trace. Like if I write Python code, that Python code is running in an interpreter that's actually running C, and then that C is something that's been compiled to assembly, and I can actually follow down the stack, and if I want, to sort of arbitrary level and understand exactly what the computer's doing. As soon as you introduce large language models back into this process, if that's part of actual like your production system, you don't have that visibility anymore, which I think is really interesting and something that's a qualitative change about the way that large language models and AI are. That's a qualitative thing that's changing with them, not just, it's faster to write code and it's faster to do certain things. But anyway, we come back to this model where we're getting ideas from our head, and we're turning them into code, and then the computer's taking the code and it's turning them into actions. It's doing something with it. And this half, barring the use of large language models and so on, is pretty much a solved problem. And this part is just us being good at code as developers. But this isn't actually what's going on when we do software development, unless you are working on a hobby project alone by yourself. What's actually going on is you're talking to the computer, and so is the rest of your team. And you're also talking to each other. Meetings, Jira tickets, documentation. And so you have these sort of two channels where people are talking to each other, one of them via the medium of a computer and code and pull requests and so on. And this is one of the reasons why writing readable code is really important. It's because it's actually also a method of communication between you. The lines of communication are flowing between you in this way, but also here as well. And so when we think about what's going on in the middle of this and like why we bother having this line of communication, it's because this part, using code to talk to each other, is not a solved problem, because we have things like different opinions on formatting and elegance and which programming languages to use and all the things you get into arguments on Twitter. But when we're building code together, when we're building software together, we're using code to communicate as well as things like meetings and Jira tickets. Our code is additional line of communication between us. It's not just the output of our work, but also a means by which we decide what our work needs to be. And to talk a little bit more about this in concrete terms, I will introduce us to our third and final philosopher of the day. This is Paul Grice. He was a British philosopher of language. And the thing that he did and introduced that we care about today is he created the theory of the cooperative principle. And the cooperative principle is an idea that it's essentially, he looked at lots of people communicating. And he noticed some trends. So these are descriptive, he noticed some descriptive rules. These aren't prescriptive, they are descriptive. Things that he noticed that came up again and again and again in situations where a group of people were trying to cooperatively communicate. And by cooperatively, I mean, we're not telling jokes, we're not lying, we are simply trying to communicate information as effectively, as clearly, as successfully as possible. And the things that he noticed 4 things, and they are called Grice's maxims. And I will take you through them now and describe what each of them are. He had the maxim of quantity. When you're trying to communicate effectively, he noticed that people will be as informative as required, but not more. I've said that these were descriptive, but I'm going to sort of say them as if they were prescriptive, as if they were commands, advice for what to do if you would like to communicate cooperatively. Be as informative as required, but not more. Don't overload people with information, right? Maxim of truth. Don't lie. Only say things that you know or reasonably believe to be true. Simple. Maxim of relevance. Only include information that you know to be relevant, or don't include information you do not know to be relevant. So if we go back to the language game that Dylan and Hannah's were playing earlier with the Lego bricks, be as informative as required. Saying which brick you need from the other person. But don't say, it doesn't matter if it's the one from over there or the one from over there for your purposes. So don't specify. Maxim of truth, say the correct Lego brick. For this one, say I want that brick, jumper, but you don't need to go and regurgitate the definition of the jumper from the Lego handbook because it's not relevant, even if it's true. Maxim of clarity, avoid ambiguity, obscure language, and presenting your message in a way that's easy for your audience, the person that you're trying to communicate to digest. And this is the one that really requires empathy because it requires you to put yourself in the shoes of the person with whom you're trying to communicate and understand what it is that how the message you're trying to communicate would be best received by them. And I love this one because these all have different ways that he phrased them. So this one is, I can't remember exactly what this one is. It's like be informative, be truthful, be relevant. And for this one, the one where he's talking about being clear and avoiding ambiguous and complicated language, the word that he used is be perspicuous. Has anyone heard that word before? Yeah, I've only heard it in this context. Be perspicuous. And it means pretty much that. It means be precise, but be clear. But perspicuous is not it, right? Anyway, be perspicuous, be clear. And this is the one that this is the hard part. This is, I think, all of these, it's fairly easy to say what they're trying to, it's fairly easy to follow these when you're communicating. But this one is the one that's really hard. This is where the human element comes in. This is where all the stuff we've been talking about so far with the pink and the blue light bulbs and signifiers really comes into play. So what does this mean for us? Those are all very interesting ways that we can cooperatively communicate, things that tend to happen when we cooperatively communicate. But I was just talking about code as a method of communication. And so we can look at each of those maxims and see how they would relate to the ways that we write code. And the first 3 are fairly easy, be a maximum of quantity, be as informative as required, but not more. That turns into things like making sure your code actually solves the stated problem. Don't use too little code, so little code that you don't do the thing. Scoping your code appropriately. These concepts turn into fairly familiar to us coding best practices. Same with the maxim of truth, only saying things you reasonably believe to be true, turns into things like validating your assumptions. If your data structure is the wrong, if you're passed in the wrong object, bail out early. That's what type checking systems do for us. Throwing errors and catching them and doing the appropriate thing rather than failing silently. All coding best practices we know and love. Maximum of relevance. Don't include things that are not relevant. Make sure you don't have unused variables. Make sure that your code is factored out into sort of functions that do one thing and do it well, for example. But the last one is the one that's actually really interesting, the maxim of clarity. And this turns into things like writing clean and well-documented code, writing clear code, focusing on readability rather than elegance. It might be possible in a Python one-liner, but is that a good idea? Like David said, in the keynote, write your code like the next person who's going to read it is a murderer who knows where you live. But the last one is the one that I really, really want to talk about. And I mentioned domain-driven design earlier. Matching your code structure to the structure of the problem it solves so that you're more clearly defining and working on the problem that you're solving. That's domain-driven design. That's what domain-driven design is. Because when we're coding and we're working on a team and we have this setup where I'm talking to the computer, but the members of my team are talking to the computer and we're talking to each other, I said that this is what software development is. This is not quite true. What software development is you have a stakeholder, the person who pays your bills, and they have an idea in their head. And what they think is happening is they say something. Well, what is actually happening is they say something. They say, okay, we have a project that we're coming up, here are the requirements, here's the time frame that we need it in. And that turns into you perceiving something as a software team, Jira tickets and so on, and measurements and ways that you can track your velocity. And that turns into ideas that you have in your head about what needs to be done, what code needs to be written as a result. And you do that, you write that code, and then the computer works on it. This is what software development is. These people and this line of communication, if you get that wrong, you don't get paid. And this is well and good, right? And this is what I think software development is. But what your stakeholders think software development is this. You have your stakeholders and they have an idea and they say things and then the computer does it. And we are an implementation detail in that process. So what David was saying earlier about AI is not going to take your jobs and whatever. The reason AI is not going to take our jobs is that AI is not good at being this translation layer yet. And even if it does get good at doing this translation layer, you will still need people in this process somewhere who know what the computer is doing. But in terms of making our lives as people, as designers and builders and maintainers of software, the way that we can make our lives easier is to minimize the amount of work we need to do as being translators between the idea in our stakeholder's head and what the computer does as a result. So when we talk about translating the idea in the stakeholder's head into code that needs to be written, we want to be doing things like reusing context, making sure that when the stakeholder says something like user, we know exactly what they mean and in which context, and using that as the context in which we write our code, define our variables, store things in our databases. This means that we are all playing the same language game together. It means that when the stakeholder says user, for example, a user needs to be able to be refunded in a different currency than the one they paid in. You have the shared idea of what a refund is, whether or not it's possible to do that. You don't have to do a complete system rewrite in order to be able to make that possible. You have a shared idea of what currency means and whether or not a user has it in their account, for example. You, your stakeholder, and the computer all have that shared idea. One of the things that I haven't found a good way to sort of explain it in the context of this talk is that when we write software, so I've said that a programming language sets the rules for a language game that we play with our computers. But actually when we write software, when we write modules and functions and tests, we're adding rules into that language game and we're specializing that game into a smaller, more precise one that we are playing with our stakeholders and the computer. And if you have to do a complete rewrite, that's like stripping back all of the rules, the more specialized rules that allowed you to communicate more concisely. And if you don't have the same idea, if the stakeholder and the computer are not actually playing the same language game, you're going to have that situation more and more. You're going to have to do more and more work as developers to translate between those two different paradigms. So we can make our work a lot easier by making sure that they match up from the get-go. Yeah, we don't have to spend effort translating if we do this right from the get-go. If our stakeholders have the same idea of what each of the concepts that we're using when we solve business problems, they have the same idea in their head that we have tried to express to the computer, we don't have to spend effort in making sure that those two things align if they are already aligned. Which sounds so simple when you say it, but I love how it falls out naturally from all these ideas of philosophy of communication that people over the last 200 years or so have been saying for a long, long time. I love that domain-driven design sort of emerges from this. It's really, really cool. Yeah. So domain-driven design, this has basically been a manifesto for it. Conclusions, because we are getting to the end, towards the end of the hour. A lot of what I've talked about here today is pretty abstract. And a lot of the difficulty of thinking about these things is that it's hard to communicate it all succinctly. It's taken about 45 minutes to get to here. And more than anything, I hope I've set some wheels turning in your head. Hope you think about the ways that we talk to each other and the kind of things that we do in our work as software developers. It's more about communication than I think any of us think. And so learning about communication can really help us to shave off some of the rough corners of communication when you're in a team meeting and you're not quite sure that you're talking about each other. Maybe take a step back and make sure that you're using the same signifiers to talk about the same concepts. So yeah, takeaways. Computers are awesome. We can talk to them in ways that we can't talk to other people. When you write code and the computer does the thing that you wanted it to do, you can know that the computer understood you, that you managed to communicate your idea in a way that you intrinsically never can with another person. And I think that's one of the things that makes programming so alluring and engaging to people, especially those of us who sometimes struggle to communicate with other people. You can know that the computer understood what you wanted it to do because your tests passed and it did the right thing. Computers are awesome. They're fundamentally different to people, and that's good and useful. Communication is hard. You're not a bad example of a human being if you struggle with it. It is intrinsically really, really difficult. I think we should all give ourselves a pat on the back for being able to do it as well as we can. We as a species have spent, as long as we've been human, trying to fix and improve our solutions to this problem. And we're all part of that every single day. I think that's really, really cool. And we can get better at communication with a little thought, a little empathy, a little investigation into how and why we convey ideas the way we do and the ways that we do it every single day in all different contexts and aspects of our lives. It can make our lives a lot easier, a lot better, a lot more fun. And you can go out into the world and go, oh, I can see that this person's using this and they're referencing that, and that's why this thing makes sense in that context and so on, which I think is just really, really awesome. So thank you for coming with me on this journey through philosophy and linguistics. I really hope you've enjoyed it. I can't wait to share the rest of this conference with you all. And that wraps me up. I've got about 10 minutes for questions if anyone wants, or we can go and get head start more coffee.
I don't have a question so much as a comment.
Mm-hmm.
So I have different linguistic game rule understanding to my wife and my children. They are autistic, and I'm not.
Yep. As I say, usually it goes the other way around when, usually we're in the minority, but
no, I'm very much a minority of my house. And it's something over the last few years we've definitely been learning more and more about each other, is understanding that what is framed in your mind is different to what's framed in mine. So how do we share a context, a concept, so that we can, get the right signifiers?
Yeah.
The way that you outlined that has been really, really good.
Thank you. That's really lovely to hear. Yeah, I mean, I watched back this talk, the recording of this talk that I gave in Porto, and I looked at it and I was like, how did I, for so much of my life, not realise that I'm autistic? It really is you sort of go, okay, no, I'm really good at communicating. I've got a system. No, for sure. It's really interesting to think about, the ways that we each represent the sort of intrinsic, unknowable sort of our internal sort of states and sort of the vast worlds that live within each of us, and try and flatten those down is something that we can communicate. And it's continually astonishing to me that we do as well as we do. Yeah, no, it's a hard thing. And one of the best things that I spend time doing is learning more about this. One thing I completely forgot to do. Go on. Oh no, I turned it off. Oh no, did I? Hang on. Oh, never mind. I was going to have a QR code for feedback, but don't worry about it. But yes, no, it's something that I find so fascinating. I could spend the rest of my life thinking about this stuff. Yeah.
Thank you again.
You're welcome. Any more for any more? We can all go and beat the coffee rush.
I was wondering ways or BDDs fitting in with this, because that seems like a way of testing, did I understand what you said
So BDD is in behavioral driven design. So I've done a bit of like behavioral driven design testing before. That's sort of my experience with it, and I wanted to include. I think in some of the speaker notes for this, I referenced Gherkin, and then didn't actually end up saying it. So behavioral driven design. So what does that phrase mean to you?
Well, I mean, I guess part of it is, right, you test to prove that you're solving the right problem. And hopefully in that, you've kind of brought up BDD as well. Hopefully you're using the language that the person who could say, yes, you're doing the right thing would agree with you.
Yes, so behavioural driven design then being the thing where you get your stakeholders to lay out the requirements in a way that is parsable by a machine, potentially. So I've used Gherkin as a language of that, where it's sort of like, it's not quite user story, it's sort of like, in this context, when this happens, this should be the result, and it's sort of a human readable but structured language. That's exactly the kind of thing I mean, precisely, where you're trying to get everybody to be using the same language to mean the same things. And then the people who are responsible for paying your bills can make sure that you are doing the work that they want you to do, and you can make sure that the computer is doing the work that you want it to do. And sort of transitively, it all works out. Exactly. And like there's a whole other talk in here about testing as documentation, and like the sort of lovely ideal world I think lots of us would like to live in, where your tests completely describe the ideal software, and then you write the software to fulfill that ideal state. And obviously in the real world it doesn't work like that, but that's the goal. Like very well connected and very relevant. Yeah. Yep.
Why don't we just make the human beings glow in the dark? Why did he jump to cats?
When there's no song.
It's a great point. I was going to say, because do you really think that humans wouldn't love to go and be in radiation so that we glow in the dark? But the thing is, we would do that with our cats too. We would go into the irradiated areas just to see the cats glow. It's no particular reason that I know of. I mean, the fundamental problem there is that you tell a human being, like, do not dig here, and what's the first thing they're going to do? It's dig here. So maybe we might be fighting a losing battle on that front. If we're all still here in that institute has a mandate to come up with something concrete, like concrete proposals by 2033. So if we're all still around in 9 years' time, we'll see if they actually manage to do that.
So a lot of like the languages we use, I only speak English. I'm assuming that generally they still, like, people who don't speak English still use the English terms
in programming. So there are programming languages you can write. Yes, you can. There are languages which you can write in. I don't know if it's simplified Chinese or sort of the more fuller alphabet, but like not always, but broadly yes, is my understanding.
So the question is, because of the overlap, like because the way that English has driven the development of those languages, I wonder how the experience might be different for someone who's got no shared context already with the programming language compared to English, already because it's like fluent.
Yeah, I mean, there's presumably people who have learned English through code, right? And certainly people all the time will learn English in order to work in software. But I wonder if people have, yeah, of course, yes, please.
Started, like most of us probably, in my early days, reading 8, maybe 10 years old, gaming magazine that had a little page at the end with in BASIC on how to do coding. Again, I'm Portuguese. Spanish is not my first language, but close enough that I can understand. So the magazines I could get were in Spanish. So first of all, I had to translate from the Spanish, and the code was in BASIC, so in English. Print something. What the hell is print? I have no idea what print is. But you just learn and associate by experience. You write print, something appears on the screen. Oh, print must mean this. So I think it is, again, just a matter of, let's say, learning by doing and trying to associate words with results. I suppose in the same way, if you go to a foreign country, you hear somebody say, I don't know, shitamase. When you go to a Japanese restaurant,
Mm,
they
mhm.
welcome you. It must be welcome. I don't know.
Yeah.
I think it's what it means. So you just start to simulate certain sounds with certain
Mm. Well, I've heard that advice for learning a second language, human natural language, where you should try and learn the way that children learn. So instead of being like, this means apple, like pom means apple, you go pom means picture of apple, and you associate directly with the concept rather than the word, the signifier in your native language, and that actually that will lead you to be more fluent more quickly. But I've never really successfully learned a second language. I know bits and pieces of quite a few, but precisely for that reason is because then you have a more direct association with the words rather than filtering it through another language that you know. All right, I'll let you guys all go free and have some coffee. Thank you so much for being here.